Hello everybody, lesson 4. Today's topic is tape measurements. Historically, distances have been directly measured by applying an instrument of known length against the distance between two or more ground points. In the second half of the 20th century, electronic distance measurement (EDM) instruments come into wide use, especially as integrated component of total station. What is the EDM? This is the electronic distance measuring device that measures the distance from the instrument to its target. EDM sends out a laser or infrared beam which is reflected back to the unit, and the unit uses velocity measurements to calculate the distance traveled by the beam. So an example of calculated measurements occur when the desired measurements is on side of triangle whose other side and angles have been measured, or when the slope distance and slope angle have been measured between 2 points and the required horizontal distance is required. So, how to determine distance? Passing is a useful method of approximate measure. Surveyors can determine the length of the path that for them can be comfortably repeated. For convenience, some surveyors develop a 3-foot stride. To determine path, you can use pathometer and pedometer. Another important use of pacing is for a RAS check of all key points in construction layout. Distances typically can be passed with an accuracy ratio of 1 divided by 100. So a ratio of 1 to 100. Okay. The next device is automobile odometer, and readings of automobile odometer can be used to measure from one fence line to another when they intersect the road right of way. These readings are precise enough to differentiate rural fence lines and can thus assist in identifying platted property lines. This information is useful when collecting information to begin a survey. Odometer also used on measuring wheels that are simply rolled along the ground on the desired route. This approximate techniques is employed where low order precision is acceptable. On the order of 1 to 100 or to 200. The next device is electronic distance measurement. You understand that this is very useful instrument, and most EDM instruments function by sending a light wave along the path to be measured from the instrument station. About EDM, we will understand from the next lectures. Also, to determine distance, you can use distance derived from the analysis of position coordinates. Special point positioning can be determined by using satellite positioning techniques and by using various scanning techniques from satellite, aerial and ground platforms. The next very popular device in North America, 18th and 19th century, is Gunter's chain. It was 66 feet long and subdivided into 100 links. It has more than historical interest to surveyors because many property descriptions still on file include dimensions in chain and links. So this chain, named after its inventor Edmund Gunter, was uniquely suited for work in English units. So one chain equals 100 links and equals 66 feet. One rod is 25 links. 4 rods is 4 rods are one chain. 80 chains equals 1 mile. 10 square chains equals 1 acre, or 10 multiply 66 squared 66, and this multiplication equals 43,560 square feet. An example. You have very old plan, and in this plan you have seen dimensions of 5 chains, 32 links. So it's necessary to convert this value to a feet and meters. So how to determine this? You know that 1 feet, one chain is 66 feet. So 5.32 multiply 66 equals 351.12 feet. And 2 meter. 5.32 multiply 66 multiply 0.3048 equals 107.02 meter, because 1 meter is 0.3048 feet. So we use the possibility to use a very useful instrument to determine the distance between two or more points. This instrument is tape. Measurements taken near electric station should be made with dry, non-metallic or fiberglass types. Fiberglass types have now come into widespread use. All types have various lengths. The 100-foot and 30-meter types is the most popular. And are used for many types of measurements where high precision is not required. So you can see closed case of type and open reel and type graduation. Type can be graduated in tenths and metric, and in eighths and metric. So printed in two sides. One side in tenths and 100ths of foot. The second side in metric with increments in meters, centimeters and millimeters. The same other variant of graduated. Many types are now manufactured with foot units on the side and metric units on the reverse side. So understand. This is a location of 0. So you can find a distance by this type. Steel types. Not so many years ago, most precise measurements were made using only steel types. Also, EDM. What is EDM? Electronic distance measurement. EDM is now favored because of its high precision and the quickness of repeated measurements. Even our Ross ground and very long distances, there are some drawback when EDM is used for single distances, particularly in the short distance situations that regularly crop up in engineering and construction layout application. Steel types are manufactured in both foot and metric units. The same like a fiberglass type and come in variety of length, graduation and unit weight. Commonly used food unit types are 100, 200 and 300 foot length, with the 100 foot length being the most widely used. Commonly used metric unit tapes are of 20, 30, 50 and 100 meter length. The steel type of 30 meter length is the most widely used because it closely resembles the 100 foot length tape infield characteristic. So, you understand about the DM regulation. That when laser or optical plant or prism pole levels are poorly adjusted, serious errors can occur in distance measurements. Errors that do diminish in relative severity as the distance measured increases. And for this reason, the steel type remains a valuable tool for engineering survey. Steel types are normally graduated in one of three ways. Consider a distance of 38.82 foot. The first one, the cut type is marked throughout in feet with the first and last foot graduated in tenths and hundredths of foot. The edge type is also marked throughout in feet with the last foot graduated in hundreds of foot. An additional foot graduated in hundreds is included prior to the zero marks. For metric type, the last decimeter and the extra before the 0 decimeters are graduated in millimeter. Distance AB is determined by holding 38 feet at B and reading 0.82 at A. Distance AB is 38.82 feet. Also, you can read 38 feet at 82, 0.82. And here distance AB 38 feet. You can read 39 foot cut 0.18 because each measurement involves this type of mental subtraction. Care and attention are required from the surveyor to avoid errors and mistakes. As the next very useful and widely used in surveying device instrument is plumb bobs. Plumb bobs are normally made of brass and weigh from 8 to 18 ounces. Widely used with 10 and 12 ounce. Plumb bobs are used in taping to transfer from tape is being held off the ground to maintain its horizontal alignment. Plumb bob string target used to provide an instrument sighting. So on this picture you can see using of a plumb bob. Also plumb bobs and their strings are used routinely to provide theodolite or total station sightings. Hand level can be used to keep the steel tape horizontal when measuring. The surveyor at the lower elevation holds the hand level and a sight is taken back at the higher elevation surveyor. For example, if the surveyor with the hand level is sighting with the instrument crosshair horizontally on his or her partner waist, and if both are roughly the same height, then the surveyor with the hand level is lower by the distance from eyes to waist. The low end of the tape is held the distance of the ground. Using a plumb bob, the height end of the tape being held on the mark. So hand level, yes, and its application. Also, you can use ebony hand level. In addition to the level bubble and crosshair found on the standard head level, the clinometer can measure vertical angles to the closest 10 minutes. The clinometer is used mainly to record vertical angles for slope distance reduction to horizontal or determine the height of the object. So you can see here an application. For height determination, a value of 45 is placed on the scale. The surveyor moves back and forth until the point to be measured is sighting. And very important that the top of the building shown here. So the distance from the observer to the surveyor at the base of the building is measured with a fiberglass tape. The hand level can be set to 0 to determine where the surveyor eye height intersects the building wall. The partial height of the building h first is equal to this measured distance, because h first divided by measured distance equals tangents of 45 degrees and equals 1. If the distance h second I height mark above the ground is now added to the measured distance, the height of the building you already found. In addition to determining the height of buildings, this technique is particularly useful to determine the height of electric power lines, very high facility, and for highway construction clearance. So the height of the building is 63.75 plus 5.55 feet and equals 69.30 feet. If the measured distance to the second surveyor of the building is 63.75 feet. And horizontal line of sight hits the building at height h second equals 5.55 feet. Also, a clinometer is very useful when working on route surveys for which extended length tapes 300 feet or 100 meter. The long tape can be used in slope position under proper tension, because the tape will be touching the ground in many places. It will be mostly supported and the tension required will not be too high. A clinometer can be used to measure the slope angle for each tape measurement. The slope angle and of course distance can be used later to compute the appropriate horizontal distance. And the angle measured distance and computed distances for a field survey summarized, and you already have found line from 22 to 23 meter that equals 1061.48. So you find these angles by clinometer, and then you find horizontal distance, and then this horizontal distance you summarize. Angles, first one, second one, third and fourth. 1 degrees and 10 minutes, 0 degrees and 52 minutes, etc.